Okay, guys, welcome everyone. This is lecture 3 for special theory of relativity. In the last lecture, we have studied about the length contraction and moving in the same direction. Now we will study about the time dilation. Okay, so in the Lorentz transformation, we have seen that in the space time, we have different time in the different coordinates, different space, and in different frames. Okay, so according to that formula, we know if there is one frame moving and one is stationary, then what will the formula for transformation of T1 prime? That will be T1 prime. Sorry, if you have, let me just show you here, not here. Just here is the formula. T prime will be T minus V by C square x divided by root 1 minus V square by C square. And if you just reverse this, then you will get this formula T equal to T prime by V by C square x in the inverse Lorentz transformation. So now you can calculate T1 prime, T2 prime, and if T1, T2 prime you know, then you can calculate T1 and T2. Okay, so here we're going to calculate the T1 and T2. Why? Because there is this clock in the S prime frame which is moving with V speed. This whole frame is moving with V speed. Now the difference between T1 prime and T2 prime will be proper time and actual time. Now we need to see that what will be the time in the S frame. Okay, so that will be, first write the expression. For T2 minus T1 it will be T2 prime V by C square divided by this minus T1 prime this. So we will get an expression for T2 minus T1, that will be T2 prime minus T1 prime divided by root minus V square by C square. This is real time or actual time, so we will write it delta T naught divided by this factor. Now we will see that if it is actual time and it is a measured time by the observer in the rest frame, then this time is greater than delta T naught, because this is less than 1, delta T will be greater than T naught. So a person or observer who is in the rest frame as compared to the moving frame will observe more time as compared to the moving frame. Okay, so that is called the time dilation. That is called the time dilation. And according to this person, this clock is slowed because it is showing the less time as compared to this. Okay, according to him, it is showing more time. It is showing more time. Here delta t is delta t naught by this, and delta t is greater than delta t naught. So it is slowed for him. This clock is slowed for him. Okay, there is this statement: a clock moving with velocity v with respect to an observer appears him to have slowed down by a factor this. Okay, it is slowed down, that's why it is showing more time now, right? So as compared to situation when at rest with respect to him. So when it was at rest, then delta t naught, and when it is moving, then it is showing delta t time, which is more than delta t naught. That's why we are calling this clock is slowed down. I hope it is clear. So we have two types of problem in the time dilation. Here in the first case we just discussed a clock is moving with respect to S frame, and clock is moving here also. So what will the delta t? Delta t naught by this observed by him. In the second case we will see that clock is in the rest frame. Okay, now just an observer is moving, and observer will measure what time. If it is at rest, now the observer here will measure delta t naught, the actual time, and the person moving will measure the dilated time, and this dilated time will be same formula delta t naught by root 1 minus v square by c square. So he gonna measure the more time as compared to actual time. Okay, and according to him this clock is slowed down. So that's what the time dilation is. Now let's discuss some examples. A rod of proper length L0 oriented parallel to the x-axis moving with the speed 2c by 3 along x-axis in S frame. Observer is also moving along x-axis with speed c by 2 with respect to S frame. The length of rod observed by the observer is. So the situation is that a rod is moving. If this is frame and this is rod, this rod is moving in this direction, and there is this is S frame, this is S frame, and there is a observer here. He is also moving in this direction. So according to this S frame, the speed of the rod is 2c by 3, and the observer speed is c by 2. So v speed of observer with respect to s frame is c by 2, and v speed of rod with respect to s is 2c by 3. Now what we need to calculate the uh, length contraction means we have it is asked that length, what will the length observed by this. So we have to make him in rest and it is moving, so we will find the speed of rod with respect to observer. VRO, you know how can we find this? VRS minus VOS divided by 1 minus VRS VOS divided by c square. So you will get the VRO, that will the speed you will put in the this formula, L equal to L naught root 1 minus V square by c square, you know the length contraction. So here this length came out will be the observed length by the observer. Okay, and answer will be 0.97 L naught. So just check it out and try to solve. If you have any doubt in this question, you can ask in comment section. Now move on to the next question. Distance of a star from Earth is 4.25 light year as measured from the Earth. Spaceship travels from Earth to star at constant velocity in 4.25 years according to clock on the ship. The speed of the spaceship in units of speed of light is. So we have to find actually the speed of this spaceship. So let's just see what is this. This is S frame, means the Earth frame we can say, and this is star, and this is observer on Earth. So there is this spaceship who is moving with speed v, and we will call it a different frame. Okay. So what is in question is distance of a star from Earth is 4.25 light year. So it is this length. Measure from Earth is 4.25 light years. Okay. Delta L naught is 4.25 light years. So this is distance will be 4.25 into speed of c. That will give us the distance, actual distance in the meters. You have to convert this. Okay. So just take it in the light years c. And why we call it the delta L naught, because it is the actual length between these points will be measured from this point only, because this is the rest frame, and there is some different length measured by this moving object, and that will be the contracted length. Okay, so we know that this distance is equal to what? There is difference in time. Okay, so if we have put what is in question is a spaceship travels from Earth to star at constant velocity. Earth to star, spaceship from moving from here to here in 4.25 light years according to the clock on the ship. So we have to find the time according to the clock which is on the ship. So we have to find this, and it is given in 4.25 years. So delta T naught is given already. Okay, so we have to find the time in this frame, the observer here. What will the time according to him? That will be delta T naught by root 1 minus v square by c square. Okay, and in that time according to him, this is time is this, and if we multiply the speed into time, that will give us this distance. Okay, so if speed is v and delta t is time according to this observer, then v into delta t will give us this delta L naught. So 4.25 years into c, this is the actual length, equal to v into the time measured by this observer. Okay, so delta T naught by 1 minus v square by c square. From here we can calculate the v. Okay, and this can go in the different way also. We can solve it the two ways. Okay, so we can solve it in this way also, that this moving spaceship is gonna measure a contracted length. So let's see what the he or she or whoever here will see the length. So this length according to this is L equal to L naught root 1 minus v square by c square, contract length, and that length will be equal to this v and this delta t naught. Okay, because now we are taking in this frame, so length also in this frame, then that is delta L, and this length equal to traveled in v into delta t naught time. So just put it v into delta t naught, and it is contract length. From here also we can calculate the v, and we will get the same, just same results. Okay, so you can solve it in both ways. Let's take one more example, the muon problem. You already heard about it, and it is very common topic, the time dilation and the length contraction. So a question is given. What is the question? So actual it is not the question, it is just a situation. Means we have muons, and this is earth frame, and this is showing the top layer of the atmosphere of earth, and the given distance is 10.4 kilometer. It is the actual actually it is approximately this distance between the earth frame and the top layer of the atmosphere. Okay, so and muons are there, so they are just dropping from this height, and their lifetime is 2.2 microseconds. Okay, and they are moving with the speed of v 0.998 c. Now we have to find that if they are going down in their this lifetime is this, are they gonna hit the earth's surface or not? Okay, so we have two frames here. One is this earth frame, and this whole system in earth frame, this distance in earth frame, and there is one more frame which is set on muons. Okay, the frame according to the muons. So we see that muons are moving with this speed. They gonna observe this length is contracted length, and that contracted length will be L naught root 1 minus v square by c square. So what length actually they want to measure, or height, h equal to h naught, this h naught is 10.4 kilometer, and this, so they want to measure 0.658 kilometer. So according to the muons, this contact length will appear 0.658 kilometer, and the lifetime is 2.2 microseconds. Okay, so we can just check it out from here, or we have one more things also, like if we it is given that this lifetime is 2.2 microseconds in the muons frame, so we can calculate the time in the earth frame also, and that time can be given from this this equal to just t naught divided by करते थे. So it will be more than 2.2 microseconds, and it will be 34.8 microseconds. So in earth frame, the time will be 34.8 microseconds, the lifetime. So in earth frame we can check, just multiply speed into 34.8 microsecond time, and the distance, if that distance is greater than 10.4, then they gonna hit, or if it is less than 10.4, then they will not hit. So let's check. Distance line v into tau naught. So first let's it is given v into tau. So here v and tau is apparent from the earth time 10.409 kilometer, and it is greater than h naught, which is 10.4 kilometer. And we also can check it out here, that if it is delta naught is this and this is speed, then multiply them, and we will get 0.6586 kilometer. And the apparent length for muon, this contact length was 0.658. So we will see that 0.6586 is more than this. So muon gonna hit the earth surface. Hope it is clear. Just watch it again. If you don't get it, then it will be clear to you definitely. Okay, so now you also see this, it's actually what I just write it in the previous page. So we are going to the moving rod problem. Okay, this is something new. So we will see that it is given rod of length L naught, this is the length of L naught, L naught is the real length. Moving at an angle 60 degree with respect to its length at speed v. With respect इसकी length इस तरफ है. So with respect to length there is 60 degree angle in the direction of moving. Find the length of the road observed by the person standing on earth. So a person standing on earth. ठीक है. So what is the length according to him of this road? So we will see that we study in the length contraction that only the length in the on the velocity component or the length in the moving direction gonna contact, not the one in the different direction or orthogonal. Okay, so we just what will we do? If it is v, then we will resolve this vector. If it is cos theta, this will be v cos theta and it is v sin theta. So only this side of length is gonna contract. Okay, what we need to find the length of the rod observed by the person standing on earth. So we have to find this length according to him. So let's say if it is v, then it is v cos theta, it is v sin theta, and only this is gonna contact, not this. So let's say here if it is L naught, then the it is L naught. Okay, so in this moving frame, if we see the coordinates L prime ox, the x component will be L naught cos 60, and the y coordinate will be L naught sin 60. Okay, and L naught will be, what will be the L naught? It is this length, and it is not L naught actually. So just forget that. We can calculate that from here directly. So only the component in the direction of the road gonna affect in the length contraction. So in the moving direction we have velocity v cos theta, and in the previous we have learned that in the length contraction we have formula L equal to L naught root 1 minus v square by c square. Okay, so here just in place of v we will put v cos theta. It will give us L equal to L naught 1 minus v square by c square cos square theta, and theta is 60 degree, so L will be L naught root 1 minus v square by 4c square. So this will be the length observed by this observer on the earth. So we take this component because only that component will participate in the contraction of length. Okay, so now we have a second case. What will be orientation of the rod with respect to x-axis as observed by the observer standing on the earth? Now in the question it was given that it is theta equal to 60 degree according to in this frame. What will be the theta in this other frame, the rest frame, according to this? So we have to find out theta prime actually. Okay, so see, let's see in this frame, if it is this and it is L naught, then L naught cos theta will be this x component, L naught sin theta will be this y component, and this overall length is given by L naught equal to root square of these. Okay, we find that L naught square will be common, and from here we can say divide just them, sin 60 by cos 60, that will give us tan theta, and or we can say tan 60. Okay, so it is just nothing special. So what will be the theta according to this frame? We will call it theta prime, and theta prime will depend on the x component and y component in this frame. Okay, so we have to find them. We see that this component, if it is moving in this direction, then only this length is going to contact, not this. We have seen previously only this length gonna contact because it is moving in this direction. So this is L prime ox, this component gonna contact by which factor? We already studied the factor. Lox will be L prime ox 1 minus v square by c square, that will give us L naught. L prime ox was L naught cos theta, so L naught cos theta 1 minus v square by c square, and this component L prime oy This will remain the same in the second frame also. L O y will be L prime O y, that is L naught cosine 60. Now the length will given by root L square by L square and O y square. So just add them. So this will be the length. Okay. So we know now this is theta prime. Sorry, theta prime was this. This was theta prime in S prime now. Now we have to find the theta actually. Okay. So we have to remove this. It is tan theta actually. Okay. Tan theta equal to, and LOY prime, LOY की वैल्यू रखेंगे, LOX that was this, and this is theta tan theta prime. From here this is theta prime. Okay, this is not equal to tan 60. Just cut it out. Okay, so just make some these corrections. So here we will see that LOY equal to this, and LOX is this. Tan theta will be LOY by LOX, and this will be given by this and tan theta prime. So now we have seen that in the theta, what will be theta in terms of theta prime, that is tan theta equal to tan theta prime by 1 minus v square by c square. So there will be difference, and from this equation we can see that theta is greater than theta prime because this is less than 1, and it will make this larger value, and theta will be larger than theta prime. So when it will move, we will see that this length contracts and this length remains same, then overall vector will comes more theta, will give more theta, so theta prime will be more. Okay, so we now just calculate the dilation in the theta. Okay, so just make these corrections, and it is just easy. Okay, let's move forward. Now this can also be seen in some more things, like area of a disk in its rest frame S is equal to 1. Okay, rest frame में area 1 है. In some units, disk will appear distorted to an observer O moving with a speed u with respect to S. With respect to S. Along the plane of the disk, the area of the disk measured in the rest frame of the observer is. So area of disk in rest frame S is equal to 1. In rest frame area is 1, pi a square equal to 1. Okay. Disk will appear distorted to an observer which is moving with a speed u with respect to S. Okay, so observer is moving, and we have to find the the area of the disk measured in the rest frame of the observer. It is observer in the rest frame, it is moving disk. We have to find this area in this frame. Okay, so we see that it is moving in this direction, then this length gonna go in contraction, but this length will not contract. So we just have to find these coordinates, then it will be easy. So this length, what will be this length according to this observer? That will be contracted length. Ax will be a, if the real is a, then 1 minus the speed u square by c square, and ay will remain same, ay equal to a, and area of then it will form a ellipse. Okay, this length will less and this is large, this will form it like that, ax ay. Then area of ellipse is pi ab, so pi ax ay, that will give us pi a square root minus u square by c square. This is 1, so the area will be this. Okay, so I hope it is easy. Now the last question for today. Light takes 4 hours to cover the distance from Sun to Neptune. If you travel in a spaceship speed, this time in minutes required to cover the same distance measured by with clock on a spaceship will be approx. So we know the time formula, it is the distance upon the speed. Okay, but we have to calculate the time, the clock on the spaceship. So we have to also calculate the length according to the spaceship. Okay, so light take 4 hours to cover the distance from Sun to Neptune. So distance will be 4 into c, and just convert it into minutes, then 4 into c into that minute part, and that will be the original length. Okay, then contracted length according to this moving spaceship will be L equal to L naught root minus v square by c square. In place of v we will get this, and this length divided by this speed will give us the time in the specific frame, obviously, because we have calculated the length in the specific frame. Then delta t naught will be distance divided by v, that is L by 0.99 c. Okay, so just put it L here and just make the dimensions correct, then you will get the answer. It was like this. This is moving with v, and we are given the L naught, which is 4 hours. In the c speed we will get this length, and according to this length will be L naught root 1 minus v square by c square, contracted length, and that length will covered in what time. That time will be distance upon speed, that distance divided by v. You will get the answer. Okay, so I hope it is clear to you what I was trying to convey, and if you have any doubt still, you can put it in the comment section. I will try to resolve. Okay, tomorrow we will in the next lecture we will try to understand the relativistic speeds or the relative speed in the 3 dimensions. Okay, so up to then, take care, thank you.